Hello, everyone. We are back for episode 3 of REHAU Academy on Air. We're going to be talking about commercial plumbing today with PEXa. So to get started, my name is Max Rohr. I'm the Marketing and Academy Manager based in Leesburg, Virginia. I like to say that I teach people to move energy well with water. Buildings account for about 40% of the total US energy consumption. And my team is really good at moving water around buildings, whether it's for radiant heating, radiant cooling, or like we're going to talk about today, water as far as the energy that we spend to clean water and move it around. We have to make sure that we're doing that well. We're not using too much energy to heat it and have it cool back down and things like that. So all utilizing PEX pipe. And my co-host today is Ali Sajjadi. So he is a business development manager and technical sales engineer based in Vancouver. He's come up through the company, started in the design department too. So he's got a great background for how the entire radiant heating, radiant cooling, plumbing industry works, geothermal from a lot of different angles. And we're excited to have him join us. So, and also you can catch him a couple times a year playing his oud out on tour. So there's even a YouTube video that you can see of him playing a cool solo. So Ali, welcome.
Hello, Max. Thanks for having me.
Yeah, absolutely. You've got a bunch of cool projects that are kind of in process right now in the Vancouver area. So we'll talk a little bit more about those as we go through the presentation today.
Yes, absolutely. Looking forward to it.
Okay, so specifically, here's what we're talking about. We're going to go over PEXa plumbing system, some of the components, kind of if you're new to PEX as a plumbing pipe component material. We'll talk a little bit about how our system works, but really we want to spend more of the time talking about the applications, problems that our customers are solving and the benefits, and then some frequently asked questions. And we'll have plenty of time for questions from the attendees. So I'll keep an eye on the chat window if you want to type in a question at any point during the presentation, and then we'll catch all the ones that we don't get to during the presentation at the end. So feel free to chat those in at any time. Okay, so to start with, when we talk about the plumbing systems that we work with at REHAU, we're starting with RAUPEX UV Shield PEXa pipe. So this is a PEXa piping material that REHAU signed an agreement with Dr. Thomas Engel to start making PEXa pipe back in 1967. So we've had a really long track record with this in Europe and then additionally in North America. So this is nothing that's new for us. The reason that we like using PEX for plumbing, great strength, temperature and pressure capabilities are well up to the different codes and things that we'll talk about in a slide or two as far as what you would need to show an inspector that this is a proper material to use for a plumbing application. Flexibility is one of the key things to speed up installations. Still tough, really uniform cross-linking with the PEXa method that we use. You could take that, the coils of pipe on the right side of the screen there and cut that into 100 different pieces and do a test where you check for the cross-linking. And with the procedure that we do and our background working with this PEXa process for so long, you would only see like a 1% difference in the cross-linking the entire length of the pipe, which is pretty unique to PEXa. Additionally, something that we're really proud of at REHAU that we've been able to perfect that for so many years. So Ali, what other things would you add about just UV shield pipe as something that can help plumbing contractors?
One thing that I want to point out is that our RAUPEX UV shield pipe has a UV protection of up to 12 months. Which is the best in class. Also, some people may start to ask questions, what is PEXa? Do we have a B? Do we have a C? And the answer is yes. I just want to quickly touch on that. There are basically three major commercial methods of manufacturing PEX pipe. And before I quickly touch on that, PEX simply stands for polyethylene pipe that the molecules has undergone a cross-linking procedure. So in order to do that cross-linking happen, there are three major commercial methods, and they're simply known as A, B, and C. They're all good products. They're all PEX, so cross-link polyethylene products. But the PEXa pipe, because it has slightly higher percentage of cross-linking, which is minimum 70% as opposed to 60 or 65 for the others. Our optimum goal for our RAUPEX UV shield pipe is 85%. So that additional cross-linking will give us some better physical characteristics when you compare it to the other methods. And we're going to talk some further details about these advantages of PEXa. But the B method is also known as silane method, which is basically moisture cure method. So when the pipe comes out of extruder, it's partially cross-linked. So the cross-linking procedure will be completed after the pipe is placed into simply a steam room, a sauna. So at certain moisture, pressure, and temperature, that cross-linking, the secondary stage of cross-linking will happen to up to 65%. And the C method, the PEX-C method, is also known as radiation method. So it's very similar to the B method. So it's two-stage cross-linking procedure. Secondary stages happened inside the reactor, actual reactor. So they put electron beams to the pipe and let that cross-linking to happen. Whereas PEXa is only one stage of cross-linking. So the extruded pipe, when it comes out, it's already cross-linked to our optimum range. And that will give us the advantage of having a uniform cross-linking as well as the flexibility, which we'll talk about in the next slide, next few slides. And which means that, for example, if you're working with PEXa pipe, some contractors probably have noticed that the flexibility of the pipe, it doesn't change if you bend it with the coil direction or against the coil direction. It doesn't really matter. So it's more flexible, and it has some other physical characteristics and advantages, the A versus the B and C.
And one of the things that with the PEXa, we have the ability to go from 3/8 inch pipe for UV shield all the way up to 2-inch diameter, because we're doing that cross-linking right at the point of extrusion. So if you've ever seen like a Play-Doh machine or a pasta maker where the material's coming out in the specific shape of the die, that's where the cross-linking happens with PEXa. So we're able to get all the way through the pipe wall really well. With a B or a C, it can be harder to do those 2-inch sizes because you're doing it in a secondary step and you have to penetrate all the way through the pipe wall to cross-link in a uniform way all the way through. Much easier to do if you just do it at the point of extrusion. So that's one of the reasons we can keep kind of the same mix all the way from 3/8 to 2-inch in diameter, and then also offer straight lengths. So we can do just, instead of coiling it right as it comes off of the extrusion line, can leave it in a 20-foot stick, which especially for commercial plumbing can be really nice to work with. So instead of having coils at 2-inch pipe, if you're going from one side of the building to the other and have a bunch of branches coming off of it, just a straight stick of 20-foot pipe is a nice way to go. So when we look at a cross section of the pipe, we talked about the basis PEX, which is clear. And then what we do specifically for our UV shield plumbing pipe is that we're going to add an outer coating, red, white, or blue, depending on if you want to use different colors or just use white for everything. And that is what is really good at keeping the sunlight off of the pipe. So as Ali mentioned, 1-year UV shield warranty that you can put the pipe out in the sunlight for up to a year. That's something that may come into play in 2020 because of the COVID related construction timelines a little bit more so than maybe other years. That if you've got a building, a high-rise commercial building that construction started right now, you may not be able to finish that building as fast as you would have in 2019. So if the envelope isn't finished and that pipe is exposed to sunlight, Ali, I think you had a job once that the timeline was so slow they had to repipe it because the PEX was out in the sun for too long.
Yeah, it was actually exactly the same application. It was a high-rise, and another PEX manufacturer supplied that project, and the pipe was exposed because the project at that time was on hold for financial reasons. And after a few months, the pipe started to degrade and decolor and become brittle. So they had to repipe the whole risers on that application.
Yeah, so that's something that could be more frequent this year with the question marks for construction timelines as we get back to work, as the virus may limit the amount of people on a job site and slow down the progress. So that's something that is definitely helpful for contractors to have a little bit more peace of mind that the PEX isn't exposed to sunlight and is covered with that UV shield jacket. That's something that is really important to pay attention to, because sunlight is not a friend of polymers, I guess, generally speaking. That sunlight will break down the plastic on your dashboard of your car or on your skateboard or whatever. The sunlight is not friendly to any type of plastic, so that's why we have a special kind of jacket on the pipe to make sure that we're protecting that basis PEX from exposure to sunlight longer. So when we get
and
to,
Max, if you let me, I just wanted to add one note to the UV discussion. I have been asked this question that how about the UV in like fluorescent lights?
yeah.
I wanted to quickly touch on that. The UV in fluorescent light is a UV-A. So the UV from the sun, it has a mix of different type of UVs, UVA, UVB, and UVC again. But UVA, which is present in fluorescent light, has very negligible effect on the pipe. We have done numerous tests on it. So if you have a piece of pipe sitting in your mechanical room exposed to a light from a fluorescent light, you shouldn't be worried about it. So it's not going to harm your PEXa pipe.
Yeah, that's a good point. The UV shield pipe would be very well qualified for some UV light exposure, definitely not as intense as the sunlight. So when we get to a fitting, we'll talk first about Everlock Plus. So this is a system that we launched in 2017. This was kind of based in the DNA of the Everlock system, which is now kind of the generic term for it is F2080. So really strong fitting compression seal that we're doing a two-step process, which I have in a video. It'll be a little hard to play it depending on the connection speed that you have, but I wanted to mention that, and I'll cover it at the end and can send a link. But we have some videos of people actually putting these fittings together to see how it works. You expand the pipe, then you compress the sleeve over it. Big advantage there is that you can pressure test right away. So at the end of the day, if you do 100 feet of 2-inch pipe and just want to put a cap on it and do a pressure test, you don't have to wait for anything. You can do that right away. So we'll talk a little bit more about the last bullet point here. Installs 65% faster than copper solder in a few slides. We've got a third-party study that we will talk about a little bit more that compares the Everlock Plus system to PEXa with just a cold expansion 1960 style fitting, as well as copper solder and copper sweat. So what else would you mention on this slide, Ali? You've had a bunch of early adopters with Everlock Plus.
One of the good advantages of PEXa is that you can expand that pipe and use cold expansion fittings, which will provide a better flow velocity and flow rates through the system because it has a minimal flow restriction because you expand the pipe and then insert the fitting into the pipe, and that's the advantage of a PEXa pipe. So you can use the cold expansion fittings on there. I also wanted to quickly touch on a couple of notes. One is the no glue, no solder or heat required to install the Everlock Plus, which is a good advantage. Also for those fellows who are listening to this that are coming from geothermal, basically you can use Everlock Plus for geothermal applications as well. Being a geothermal contractor myself, I've had a lot of challenges when I was installing a high-density polyethylene pipe in trenches full of water and dirt, and you need to make a nice, clean joint with heat fusion. It's very challenging, and you have to carry your power line in trenches full of water, so there are also safety hazards. So this can be a good solution for the geothermal applications as well. Also, the immediate pressure testing, I have heard a lot of positive feedbacks from those people who have switched over to Everlock Plus for this feature, because as soon as you complete your installation, you can perform your pressure test right after, which resulted in a lot of labor saving on a given project. That can be exponential for commercial applications for sure.
Great. Yeah, and we'll talk about that with the case study a little bit and show kind of connection by connection where people save some time there. So at REHAU, we like to be flexible for the different the tools and systems that you may already have on your truck. So we've also released REHAU F1960 cold expansion fitting system as well. So we have two different fitting systems that will work well with PEXa. These are both great systems. If let's say you've got 10 trucks and you're interested in switching to Everlock Plus, but aren't going to retool everybody this year, especially, then you have the ability to just from the same catalog under one warranty, the 25-year limited warranty, use a mix of Everlock Plus and 1960, however that fits for your shop this particular month or year or whatever. So that's available from 1/2 to 1 inch right now, and we'll be expanding both of those fitting lines in the future, so we can kind of adapt to whatever fitting system you like to use right now. As far as codes and standards go, I'm not going to go into a lot of detail here. The answer that we would give an inspector or something like that is that PEX will work for that, especially in any sort of commercial plumbing application. These are the standards and different certifications that we have or adhere to with our product. If something like this comes up and you've got specific questions in a jurisdiction, they want to ask some follow-up questions, we're happy to walk you through those. But basically, we've kind of checked all the boxes with the different codes that you would need in the US and Canada to do these projects, commercial plumbing with our PEX. Okay, so now let's talk a little bit more about kind of increased reliability. So some of the things that have come up with copper in the field. Do you want to talk about some of these, Ali?
Absolutely. Corrosion buildup. It reduces the flow. Also, copper pipe is vulnerable to cold temperatures. Can cause pinholes and leaks. Also, it scales way quicker and can cause flow reduction as well. Also, there is no water hammer reduction with copper pipe, for instance. Also, high fluid velocity that can be erode copper. These you won't see these in if you use the RAUPEX pipe because of the a better enhanced water hammer reduction. It's also lightweight as well as the advantages that are. We're going to talk about that on the next slide, I believe. But the one of the major things that I have seen in the field is the copper pipe and cold temperatures. In many applications, we have seen that the copper pipe was frozen and it caused leaks. Also, in the long run, the life expectancy of copper pipe is not as good as PEXa pipe. So in many applications, we do see repiping of the copper pipe. And also obviously the flow characteristics of RAUPEX. We can simply run 8 feet per second for cold applications and 10 feet per second for cold applications and 8 feet per second for hot water applications, which is nearly double the capacity of the copper pipe, which is maxed out at 5 feet per second at 140 degree, which will help with reducing all these issues that we have seen, such as corrosion or scaling or pinholes in copper piping.
And I think particularly for you in Canada, where freezing, the cold season is a little bit longer than in some of the warmer plumbing states, that is something that water will freeze when it hits 32 Fahrenheit or 0 Celsius. That will happen regardless of the material that you use. PEXa specifically has much better freeze resistant characteristics that if there's room for that pipe to move, so if it's in an exterior wall with no rigid fittings, or something like that, it can freeze and then come back to its original shape. Copper will break. I forget what the number is, but water expands something like 11% in volume. When it freezes, that will break copper 100% of the time because it's a rigid material. So that's something that can be really helpful. Again, these long construction timelines, that if there's water sitting in a plumbing system and they haven't quite finished the project, as soon as it starts to get to the end of summer, that's something that we don't really want to encourage, that you leave a system to freeze, but you might dodge a bullet with PEX where it would have frozen with copper for sure. So another thing that we mentioned, especially in urban construction markets where there are a lot of eyes on job sites, people don't steal PEX the same way they do copper. So if you've got 2 inches of copper pipe laying all over the job site, that's something that come the middle of the night, a local thief might be more willing to take that and take it to a scrapyard than a box of PEX-8 pipe somewhere stacked up against the side of the building.
Yeah, for sure.
So a big part of the presentation today is I wanted to kind of talk to Ali about some of the commercial high-rise and kind of mid-rise projects that he's working on in BC, in the Vancouver area specifically. That's been one of our huge markets for this type of commercial plumbing application. So do you want to maybe walk me through a couple of the projects that you're excited about in your market?
Yeah, there's actually quite a few of them. We did projects in universities and schools thanks to a higher capacity of PEX-A pipe, generally speaking, because of having the higher capacity in terms of flow rates and velocities. In some applications, we have been able to downsize the original design from 1.5 inches to 1.25 inches, or from 1.25 inches to 1 inch. Again, thanks to the higher capacity of PEX-A pipe. These photos that are shown here is for a project that we did in University of British Columbia. It's an 11-story building. We are also doing a lot of residential condominiums. Currently, we are working on a multi-tower project in Vancouver. There is a 21-story, a 13-story, and a couple of 5-story buildings that are going up for a total of 336 units. That's going to be completed in probably in about a year or so. The construction is ongoing. We also have done a couple of other tower projects in Surrey, as well as a bunch of 6-story walk-ups, either wood frame or concrete buildings, luxurious home with LEED Gold certifications, and basically these projects, and we have done them in interior BC, in North Vancouver, in Surrey, in different locations around town. We are also involved in another tower project. It's a 28-story building, 236 units. It's another residential. It's a mixed-use residential commercial application.
And I think that those are interesting projects too, because I think often commercial plumbing with PEX pipe is something that maybe, and we have case studies like this too, that is seen as maybe a 2- or 3-story townhouse complex where they might just bump into 1.25 inches or 1.5 inches or something like that. But it's been very cool to see that these projects that you've worked on, this is modern high-rise 28-story commercial construction, and this is something that definitely 5, 10, 20 years ago would have been copper for sure. I think that a huge advantage with these systems is that you can just do a pressure test per floor. You don't have to wait for anything and keep moving, especially with as much of a premium as a mechanical chase can be for all the trades, to be able to just kind of weave through that with the flexible PEX-A pipe. Or to have the ability to stay out of the way of the other trades sometimes is worth its weight in gold. So yeah, I just wanted to kind of talk a little bit about some of the projects that you've worked on there, and I think that it's great to see that this is moving kind of past the traditional large home or small townhouse complex and into these big commercial buildings. So yeah, thanks for covering
Yeah,
a couple of
absolutely. And
those stories.
the advantage is actually that I talked to contractors. Some of them have provided with feedbacks. One of the major things that they have mentioned is that quick pressure test availability of the fitting. As soon as you put it on, you can pressure test, and it was a huge advantage for them. It eased up their installation procedure, saved a lot of labor, as well as the inspection procedure was also much easier and quicker for them. As you mentioned, they could do it per floor and get over it. So also one other thing that is, again, this is a feedback from the field. Every single fitting that they have put in together, they can rest assured it's done properly, because again, we're going to talk about this, but because the procedure doesn't change by size, or it doesn't going to be impacted by the temperature outside. It's a consistent procedure, so installers can get used to it after installing few joints, and that also was another big advantage and a good positive feedback that I have received from the field.
Yeah, great. That's helpful, because I mean that's the goal is just not to have a dry fit fitting or something that you forgot to squeeze with the copper press, or CPVC forgot to glue it or something like that. As soon as you turn water onto the system and flood a brand new building, nobody's excited about that. So this gives you the ability to move fast but still have that peace of mind.
Yep.
So as far as kind of utilizing best the flexibility of the pipe and some other advantages here. So no solder or glues like we talked about before. Job site theft, I did put that in here. I forgot that was one of the bullet points. And then another big one to quantify it a little bit is the weight. So if you were going to do a commercial building and had to do an entire floor of one of those big towers or something like that, you can almost assemble and make these connections as many as you want on the floor, and then lift a big spool of it up and then hang it. Because if you're going to do 100 feet of 2-inch type K copper, you're talking 206 pounds. 100 feet of 2-inch PEX is only 60. So, you know, a person or a couple people on a ladder can lift up a much longer stretch of PEXa, and then you even have the flexibility. If you were off a 16th somewhere in your measurement, you can weave through that. Or kind of like the photo on the top right of the slide here, that you can just use a multi-port T like that and spread out and go to the different units as if you were doing a kind of a remote home run or a remote manifold type system. So you have the benefit of using the rigid fittings and straight lengths if you want to, or you can really, especially with the smaller diameters, weave around all sorts of things. The picture in the center there, saving a fitting in the wall is great by any standards. We're very confident in the fitting system that we have, but to snap the pipe into one of those supports with the bend saves the fitting, and a little bit just a minor improvement in flow characteristics and things like that. It's a big advantage. So what are some other things that you've heard from your installers, Ali?
Well, in colder climates, if you want to install like a fitting at -20, -30 degrees, it might be challenging. Whereas I actually did this test myself on a job site with some contractors. It was nearly -38 degrees in northern BC. I was on a job site, and we did install the Everlock Plus and immediately pressure tested it with no issues. So I wanted to make a note that the RAUPEX pipe is flexible to -40 degrees. That's the pipe itself with no water, obviously, which means that you can expand the pipe and install a fitting even at those cold temperatures. Hopefully nobody have to work at -40, but if it happens, if you're in a cold in cold conditions, you can easily expand the pipe, put the fitting together. Obviously, there are some considerations for the tool itself, because every tool, it has its limited operating temperatures. So if you keep your tool warm, you still can expand the pipe and insert and install your Everlock Plus fitting in colder temperatures as well, which is it has been a big plus, and a lot of positive feedbacks again about Everlock Plus installations in colder temperatures.
Great, yeah, and that, I mean, at negative 40 degrees, your phone's not going to work very well either. So just keeping a hydraulic tool warm is a good practice for any other tool that's on your truck as well. So yeah, but that's something that I feel like, especially north of the border, the customers appreciate that the system is going to be reliable even when it's cold, because it can be cold along part of the year up there. And again, with COVID-19, some of these projects may stretch deeper into the winter than they normally would for new construction and things like that.
Yep.
All right, so when we talk about the flexibility of PEX pipe, we have on the right side of the slide, if you're looking for numbers, kind of the typical bend radius. So an 8 times the OD bend with a pipe of 180 degrees. That's pretty easy to do. You can go down to 5 times the OD cold, and then there's even with a little bit of heat from like a paint stripper, something that just blows warm air, you can get a little bit tighter bend. For the most part, people are using that 8 times the OD, 5 times the OD to make a tight bend. And as we showed, either a fitting or the little bend guides can help you with PEX, not even have to use a fitting and make a tight turn like that. So the next slide, we're going to talk about the specific layout of the time study that we commissioned. But because of this flexibility, that was part of the reason that we found with this time study that the Everlock Plus system with the PEXa pipe was 52% faster than copper with press, and 66 faster than copper with solder. And again, with the solder fittings, you're not going to be ready for a pressure test immediately there either. So the flexibility really makes a big difference, and that's where you kind of see it outside of being able to navigate around something that's in your way in a chase. Really helps to not do as many fittings. I mean, I think that the REHAU sales guys in the room are probably excited about selling as many fittings as they can. But an advantage that installers should take the advantage of our system is that you can really reduce the amount of fittings. So you don't have to go fitting for fitting with copper. That's not really best utilizing the system. So we would recommend more multi-port tees and kind of navigating your way around to save time, and we'll cover that on the next slide here. So there was a Home Innovation Research Labs is in the Metro DC area, and they do a bunch of cool kind of experiments. They have this big warehouse, and what they did for this particular test is they built the floor plans down at the bottom there like a hotel room floor plan. So this is just inside of another building for the purpose of the test. They took a set of blueprints for a hotel, and they recreated these rooms. And then they had 40 total fixtures, 2 hallways, 8 guest suites. And then what they did is they piped it with 4 different materials. Took one out, put another one in, and measured by the minute. They had a researcher standing with a clipboard to document every single minute of what the installers were doing. So if it was copper, if it was reaming the pipe, or whatever the case was, everything was documented. And they found in the graphic on the right there that you could do all 40 of those fixtures ready for pressure tests with PEXa and Everlock Plus in 152 minutes. PEXa with cold expansion, so this was the 1960 system, 194 minutes, and then copper with solder, a lot more time, and then as well copper with press fittings. Really a big difference there though. So even with press that you can pressure test right away and things like that, still a lot of prep work, and you're still working with the rigid material, where with both of the PEX options you can kind of weave through that building a little bit easier. So the actual installation wasn't done by researchers. It was done by licensed plumbing contractors with 15 plus years of experience, and I believe they switched, so each person did kind of each role going through. So they both did each step to get a really good time number consistently. So it wasn't just if one guy dropped the the fitting that he was standing on the top of the ladder with, that it screwed up the numbers. They did a good job of controlling the variables well and documenting each step there. So that's something that we like to talk about a lot, as just kind of not just me saying it as a REHAU employee, but actually a third-party commissioned time study to see how this works. This link here, which I'll click on, let's see if I can get this to open. I probably won't play it because it's going to really slow down the webinar, but this video, which I'll kind of chat the link to everybody at the end of the presentation, goes through a lot more of what was actually going on there, and then we have a full hour-long PowerPoint about this as well. So you can see kind of what was behind the scenes here, how we did that time study. Anything else you want to add about that, Ali?
Well, it's pretty self-explanatory, and I encourage everybody to have a closer look at that time study, because it has really good information in there. And to add to that, we didn't really consider like cold temperatures.
Yep.
In this time study. If it was a colder temperature, obviously these chart would have been towards the advantage of using Everlock Plus even more, because even in cold temperatures, if you put that fitting together, you still can pressure test it immediately. Whereas with some of the other systems out there in the market, you can't really do that. You have to wait a few hours, or maybe go back and or go and come back the next day to perform your pressure test. And these can add up, and it can have a big impact on the labor cost savings, generally speaking. And also another note about the press system, quickly about that. The press systems, they're not cold expansion fitting systems. So you basically insert the fitting into your pipe, and by doing that, you're reducing your inside diameter, which can basically increase your head loss, as well as if you look at the, for instance, the equivalent length of a given fitting, the Everlock Plus has a huge advantage over there because of the larger ID it has compared to the press systems or the regular crimp applications.
Yeah, and you would notice
like,
that like
a 1807. Yeah.
Like a PEX B or a PEX C, that you don't cold expand, that the fitting has to go inside of the inside diameter of the pipe. You're going to have more of an equivalent length there than the cold expansion options, Everlock Plus in 1960.
Yep, which can result in a more efficient pumping system or pumping design as well.
Sure, yeah, and then for a big commercial hotel or something like that, better flow rate to all the plumbing fixtures. So one of the ways that you can still save time with a commercial plumbing system with PEX is that if you're just going to support PEX pipe, I've got an example on the right here, 3/4 inch pipe, bare PEX pipe, you'd have to support that every 32 inches, which is more than you would need to do for copper. So a good way to go for commercial plumbing applications is to use this galvanized support channel, and it allows you to do 8 feet between hangers. So there are a couple advantages to that, but really what I like about it is that if you're going to do a big job like that, you can snap that support channel on when you want to run a long, horizontal run and use it as a straight piece. And then if you had to do a 5-degree offset somewhere, you can still do that because you still have the flexibility of the PEX. So it's kind of the best of both. You've got the flexibility and the rigidity. It helps to be flexible to get around something, you can do that. If it helps to put this support channel on and not have to do as many hangers, you can do that as well. So that's another way that the overall installation time can really be cut down, so you're not taking a penalty by switching to PEX with so many additional hangers. So that's a nice way to do it. Here's an example of what that looks like in a commercial installation. And then one of the things that I wanted to mention here, and they're going to be in your, as an attendee, look for on your toolbar handouts. We've got, this is a pretty complicated Plenum topic that it comes up all the time when we talk about commercial PEX piping for plumbing applications, and we have the way to adhere to this ASTM E84 criteria. So essentially what they're looking at is that in a plenum, in an unoccupied space where there's air movement, if a fire starts, can it transmit down a material and move to different parts of the building? Because that can be a very bad scenario if you can't see that there's a fire and it starts moving, laterally through a building or vertically with the material. Like worst case scenario would be like a dynamite fuse or something that it's just zipping from one side of the building to the other. So PEX doesn't burn like that. It burns like a candle. It is still a hydrocarbon, so it eventually will burn, especially once the pressure's been let off of a plumbing system. But what we can do additionally with that galvanized support channel is it helps us meet the C84 criteria ASTM standard as far as the flame spread and the smoke's developed. So when they do this test, they basically take like a big blowtorch type thing and hit the bottom of the material and see how quickly it spreads down the length of like a 20-foot chamber. With the galvanized support channel, it's just hitting that galvanized metal from the bottom, so the flame doesn't spread as quickly and it doesn't smoke because it's not dripping back down on the natural gas flame that's coming through the box. So kind of a weird test. Eventually, if a building burns down, everything's going to burn, but what this shows is that if you use that galvanized support channel, you're going to benefit from the installation time, as well as you're going to jump into with both of the Canadian code cycles and in the US ASTM E84 compliance. So again, we have two different technical bulletins that are attached, one for US and one for Canada, that go into the very specific details of how far you need to space these apart, and if you use galvanized support channel or E84 rated insulation, how to do that. So we can help you out with any of those projects and help figure out what you need to do to be in compliance. Is this something that you get a lot of questions about as well, Ali?
Yeah, this is a common topic and somewhat confusing, as you mentioned, especially considering the Canadian standard, because in Canada we have ULCS 102, and it has two versions of 2007 and 2010. Some building codes in certain jurisdictions, they have like the building codes are updated back in 2015. So on those building codes, they are referring to the 2010 version of the ULCS 102. But in some jurisdictions, the building codes hasn't been updated yet. So on the books, some of them, not all of them, but some of them are referring to the 2007 version of it. A majority of jurisdictions, they have actually adopted the 2010 version of the ULCS 102. But I encourage people, if they have any specific questions about this flame spread and smoke develop ratings of our product, they can always reach out to us directly, and we can provide them with more detailed and more specific information. But generally speaking, if you use these galvanized channels or the insulation, fiberglass, half-inch fiberglass insulation in a plenum, you can run your pipe side by side. There is no minimum spacing required. If it's half-inch pipe, regardless, you can run the bare pipe side by side. Whereas for larger diameter sizes, you either have to space them about 18 inches, or if you want to place them closer to each other, you need to either use these galvanized channels according to the code or the half-inch fiberglass insulation. And Max, also another quick note about the galvanized channels that are sold by REHAU. These ones, if you look closer at these galvanized channels showing on these photos, you probably can see that that channel is designed in a way that it covers more than 50% of the pipe, and the pipe snaps into the channels. So there is no need for additional fasteners. And also the material that we use to fabricate these galvanized channels is a heavy gauge stainless steel. So it's very strong and it doesn't bend, it doesn't change shape, and they come in 19.5-foot lengths to go perfectly fine with your 20-foot straight lengths of pipe. You obviously can cut them to the length using the burring tool to get rid of sharp edges. And as soon as you snap the pipe into them, you're done. You can hang them right away. There is no need for additional channel fasteners, which can also help with a more speedy installation.
Yeah, and you can see in this graphic that it's more than 180 degrees of that pipe coverage, so it does physically snap into place, and you have to kind of peel the PEX back out of it to get it out of that channel. So a really good tight fit for the installations. Okay, so hot water recirc is something that kind of really exposes the limitations of really what we're asking designers to do to move hot water around a building for potable water. So in a sense, chlorinated, hot, mineral, full, fresh water from the municipality is kind of the worst case scenario to move through any sort of pipe. So this is what you'll notice in a copper system that will scale a pipe really quickly, or if the velocity is too high, can cause pinholes and things like that. So PEX is better suited to deal with those two things because it's not going to, we can go with a higher foot per second velocity through the pipe, as well as it doesn't pinhole the same way that copper does or scale. But one of the things that that comes up is we still want to, in any scenario, I would recommend using some sort of timer or aquastat or occupancy sensor control. So we're not just doing kind of a wild loop of an uncontrolled domestic hot water recirc line, 140 degrees Fahrenheit, 24 hours a day, 7 days a week, isn't good for anything. It's not useful for the energy that you're gonna have to use to heat that water. If no one's in the building, no one's using the hot water late at night or something too, you don't need to do that. And just very hot chlorinated mineral packed water is going to wear out plumbing materials, your components, your ball valves, all of those things a little bit faster. So having some sort of control on that, so it's not just running wild all the time, can be very beneficial just to the plumbing industry, so people aren't repiping copper more frequently or whatever the case may be. But one of the things that also brings up, especially now as people are kind of going back to work in these large commercial buildings, is as designers, what we want to pay attention to is in a new plumbing system, minimizing the amount of dead legs that are in a system. So the way that a dead leg is kind of qualitatively defined is just any dead end street. So somewhere that there's no potential for recirculation through the system. So out to these fixtures, if you didn't use a shower for 2 years and then turned it on, you have kind of a big dead leg, a little bit of volume of water right there that hasn't been circulated, hasn't been warmed up, hasn't been flushed through in a very long time. So a recommendation for a plumbing system to whatever extent you can is to minimize these dead legs. It's something that's a little bit tricky in our industry, because what is a dead leg as far as the amount of feet or inches or volume of water, nobody really wants to define that, but we want to minimize it as much as we can and get those multi-port tees as close to the fixtures as possible and things like that. The reason that comes up is because of Legionella bacteria. So Legionella is something that's found in natural freshwater environments. You can drink it and it doesn't harm you at all. It's going to be in lakes and streams and stuff like that. It's not a big deal to drink a cup of water that may have some Legionella bacteria in it. It is an issue if it becomes vaporized and you breathe it. So if it's kind of steam coming off of a hot tub full of Legionella bacteria, large plumbing systems can be a big volume of warm water. Cooling towers have more recently been in the news as a big issue with Legionella, because they're just kind of steaming that bacteria-filled water that people can breathe as they're walking by, or even things like decorative fountains. So what's happening here is that out in a lake, the Legionella bacteria doesn't, it may be kind of stagnant, it's not really growing, because the bacteria likes 68 to 122 degree Fahrenheit temperature water in order to start growing and growing faster, so 20 to 50 Celsius. At 131 or 55 Celsius, the bacteria starts to die, so that becomes too hot and kills it, but not immediately. So the issue here is that in a commercial plumbing system, especially one that has been stagnant for the entire summer, maybe for some of these large commercial projects, is that's a lot of dead end piping that hasn't been flushed, and it potentially has been maintained right in that bacteria growth range. So it's something as designers, we have to figure out a way to disinfect this this water as much as we can. You can never prevent it. So if we get it up to that high temperature, we can basically scald the bacteria out of the water, or at least kill it and bring it down to lower levels. You're going to continuously get more Legionella bacteria as you get another cup of water from the municipality and things like that. But you have to be careful that you don't just turn up your domestic storage tank set point to 180 degrees, because you could really scald somebody. You could really hurt somebody with that hot water pumping through a domestic recirc system. If you had 154 degree Fahrenheit water, you would get a first degree burn immediately and a second degree burn in 1 second if that came out of your sink or something like that. So we can't just go to the moon with our temperatures to kill Legionella without also weighing the risk of scalding someone. So some things that you can use here as installers and system designers is point of distribution mixing valves and point of use mixing valves. So right under the sink or leaving the mechanical room to make sure that you're killing the bacteria before it gets to the point that it's scalding someone at the fixture. So this is a pretty complicated topic, and there are, ASHRAE's kind of taken a swing at it with standard 188 to start to put some a little bit more information about, okay, how specifically am I supposed to address this as a system designer? IAPMO has a task force that they're working on defining some of these things a little bit better, because it's a complex topic, and if you are killing the bacteria well, you could risk scalding someone. So this is a very simple chart that I put together, and I'm talking specifically about the DHW storage tank, not all the distribution lines and the recirc lines and things like that. But in my house right now, we've got 2 bathrooms. So the volume of water, the biggest volume of water is going to be in the water heater. There's not as many gallons that are moving around my my house to the different fixtures. The biggest volume of water, the biggest part of the system that could grow a big amount of Legionella bacteria would be the water heater in my particular scenario. So what you could do is maintain the storage tank temperature between 131 and 140 degrees. So you're staying below those OSHA recommendations for scalding, but you're staying in that bacteria kill zone, basically. As one recommendation that, I had to piece this together from 2 different sources, so it's hard to find a ironclad definition of how to kill Legionella bacteria or how to work in these systems. The answer is not going to be bump the chlorine up to water park levels or use UV disinfection or things like that. In Europe, they've been kind of dealing with this longer. The answer is definitely thermal disinfection. Just increasing the water temperature to kill the bacteria has the least amount of downsides compared to just bumping the chlorine up to the moon, and then you start to ruin all the other components in the plumbing system, and you're drinking water that the EPA says you shouldn't be. That's kind of going overboard the other direction, whatever the chemicals may be. So we can do this with thermal disinfection. We just have to be careful and use the right mixing valves and recirc strategies and things like that. So definitely not a finished story by any means, but wanted to just kind of bring that up a little bit to give the designers on the line an idea of kind of the balance that we have to work with right now. Okay, and then we wanted to, and this was a quote from one of our earlier projects, that from all the products I've used in the past, Everlock Plus is by far the fastest and simplest for my employees. They're always scared to try something new, and once they did a few joints with it, their fear went away and they loved it ever since. So we can talk for an hour about how cool we think Everlock Plus is, but definitely when we see the successes that our customers have had by going out on a limb and trying a new plumbing system, we're happy to come give you a demo and things like that through our sales network and our rep network. We think that we can help you provide better assistance for these types of plumbing systems. You guys are the installers, and the contractors are the heroes definitely in this scenario. But if we can help you finish a job quicker, especially in this COVID-19 summer, If it's something that you can get in and out of a job 5 days quicker than you would have using a different fitting system, switching to Everlock Plus, that hopefully is a big win for you and for your customers and for your cash flow potentially. So that's something that is what we like to mention. And again, if you've got great success stories, we'd love to hear that. We like to kind of put together our highlight reel of what contractors are doing to make systems work really well and things like that. So I've got a couple resources to go through on the website as well. Ali, did you have anything else to add to wrap this up?
No, man, the good information. Thanks very much. I think we covered good points.
Great. And then 2 things that I want to add as well. Don't reuse polymer fittings. You can see the photos on the right here, people trying to cut the fittings apart to reuse them. If you cut through those sealing edges, they're going to leak. So that's something that, while I've got the captive audience here, I want to mention that. Just toss those fittings and start over with the new one. It's not even worth the labor hour that it would take you to get that apart. Another thing to mention, and we've got some more details in Technical Bulletin 266 on our website, PPSU fittings, which is the polymer material that we use for the Everlock Plus fittings and really what everybody else in the industry is using for plumbing fittings. Here are some chemicals that we know are an issue with these fittings that you want to protect them from, and we have specific guidelines in that TB 266 that I can show you on the website in a second. But you do want to make sure that you're keeping things like PVC glues and primers, paints, adhesives that aren't the tapes that we list as appropriate, fire stops, insulation, expanding insulation foams and things like that. Be careful with those. It's easy to protect the fittings. The pipe is a completely different thing than the fittings as far as some of those chemical compatibilities go, but we can help you through any of those questions that you might have. And then as far as some of our resources go, LoopCAD for radiant heating and cooling design, and then we now have Plumbing CAD that has all of our plumbing parts in it as well, so you can do designs and takeoffs, and that's how you can really dial in the fittings that you need and also make sure that you're going to be using the right foot per second flow rate and things like that. So those are the other resources that we have. Let me take a break here, and I'm going to switch back over to the website. So if you go up to the top of the website here and click on Resource Center, so I'm looking for TB266. You can just type that right in, or you can go through and select the specific divisions and things like that. TB266 is going to give you specific examples for protecting the Everlock Plus joints, when to do it, how to do it, things like that. Here are the different tapes that you can use to protect the fittings. Those can be helpful. These tapes, like these Scotch tapes, are available from our catalog, or you can get them at your big box home improvement stores as well. We don't really care about selling the tape as much as protecting the fittings from the different chemicals that I talked about a few seconds ago. So we've got a question into the chat as far as chlorine resistance for hot water. So here specifically in this Technical Bulletin 135, this is kind of what we're talking about to put it into numbers for the pH, the concentration of free chlorine, the water temperature, water pressure, and then the ORP basically for the total system. So in these cases, we've got some examples of if you're going to do a recirc system and have a timer, maybe it does even go up to 140 degrees Fahrenheit, but there's some sort of timer aspect to it. Those are the ways to kind of comply with that. And these chlorine numbers are not really numbers that we made up. These are kind of what the EPA defines as water that you should be drinking. So at some point, you could turn the free chlorine way up in a way to try and protect the system better for Legionella. You're going to be breaking some of these free chlorine rules that may be an issue just for outside of PEX manufacturer standards, but for human consumption. People aren't really supposed to be drinking pool water. But if you do need a document that goes into a little bit of detail of what specifically are we talking about and what are we comfortable with from the PEX side, we can present that to you there. And then I've got another note about the presentation. If somebody is looking for a PDF of the presentation, I'm happy to pass that along. What else here? So the REHAU Everlock Plus installation videos on our REHAU hands-on quick instructions and tutorials is a great way to see how to put these fittings together. There are videos here of this one right here is 40 seconds. It took us to put together a 2-inch Everlock Plus XL fitting that was ready for pressure test. So that's something that's really helpful and maybe useful to show your installers so they kind of know what the system is before you even do a demo or something like that. This video right here is a trailer for that Home Innovation Research Labs time study that goes through the results there. And again, like I said, there's a full hour-long video where we go through all the slides as well. Okay, and then it looks like one other note in the chat is that the first handout isn't available. So let's see what that would have been. So if you are having an issue with the downloads, the best place to look is always on our resource center. So na.rehau.com, click on resource center at the top. Then I just typed in Plenum. So for installations in the United States, you can download this here. And this is a good place to go to because if there is some sort of code update, we'll change this and it will, the live version will always be on the website. So you'll get the most recent one. Same thing for Canada. So here are the different graphics for how you can do minimum spacing and things like that. Okay, and then the other resource was the plumbing design guide, which is also available here. PEXa plumbing design and installation guide, and that's going to have a lot of different information too. So all sorts of things from water quality to bend radius, ultraviolet radiation, things that we've talked about. This is kind of our master document for plumbing applications, and it's definitely a good thing to take a look at. So I think those were the questions that I had in the window here. Ali, do you have anything else that you want to add before we wrap it up? We can stay on the line a little bit longer, but anything else you want to throw in?
Just a couple of notes. When you're using different tools on a job site, including, for instance, Everlock Plus or any plumbing tools or any other tools that you use, make sure, because certain polymers are vulnerable to certain chemicals. So to prevent any potentials for any issues or concerns, make sure, for example, your gloves are not touched by like grease and stuff like that. Or for example, if you're using the F1960 tools, that cone needs to be greased every once in a while, same as with Everlock Plus. Make sure you don't apply too much grease, because if that grease comes in contact with the pipe or fittings, that can be a potential for damages to that PPSU material. And as you mentioned, Mac, it's not just relevant to REHAU branded products. It's applicable to all polymer fittings and plastic pipes, generally speaking. So always be careful about these matters. Fire stopping, if you're not quite sure, you can always reach out to REHAU sales reps as well, just to make sure the material you're using is compatible with the product, or would you need to protect, for instance, your fittings by using linerless adhesive-free tapes. We mentioned that technical bulletin that it shows that you can wrap the fittings with some sort of tape, but make sure it's not, for instance, duct tape, because duct tape also has some chemicals in its glue that can potentially damage that product. So we always encourage to read the instructions, and if you do so, there will be a system that works flawless and it won't leak.
Great, yeah, thank you. So it looks like we've gone through all of the questions here. So let us know if you have any additional questions. You can take a look at our website as well, Mechanical and Plumbing. And then we've got a whole bunch of additional information here about plumbing on the website too. So let us know if you need anything else, and thanks again for your time.